we are going to show that we can represent square root of 9.3 on the number line. What is special about the number is it is not a perfect square. Also we have a decimal number inside the square root. So the first step is we draw a line segment measuring 9.3 centimeters. So from 1 I am measuring 9.3 centimeter here. 9, then 9.1, 2, 3, 9.3. We will need another 1 centimeter. So I am going to draw up to 10.3, or what we will do, one thing, we will draw a big line and we can mark 9.3 here and 10.3 here. This way we will get a straight line. This part is not needed. We need only this much. We have A, B, C. From A to B, the length is 9.3. B to C is 1 unit. So the total AC will be 9.3 plus 1, that is 10.3. We have written two steps of construction. First one is draw AB equal to 9.3 centimeter. Then we are producing the same line to C so that BC is equal to 1 centimeter. Total AC is 10.3. Whatever I have drawn here, I have written the steps of construction. This will mark as 1. Now what we should do is we need the AC. No? For AC, we are going to draw the perpendicular bisector. To draw the perpendicular bisector, we should take more than half of AC, not AB, remember AC. So more than half of AC, you cut one arc above the line and another arc below the line segment. Then from C, see where I am keeping the compass, not on B but on C. Now if we join these two, we will get the perpendicular bisector. You can draw using dotted lines itself. We have the perpendicular bisector. What we are going to do is, I am going to mark a point O here with O as center and OC as radius. I am going to draw a semicircle with O center and OC. So one end of the compass should be at O and the other end at C. You draw a semicircle. We have drawn the perpendicular bisector, and from this point O as center, we have drawn a semicircle. Now I have written the steps of construction for the next part also. What have we done? We have first drawn the perpendicular bisector for AC. It is meeting AC at the point O. Then with O as center and OC as radius, what did we do? We drew a semicircle. So up to that I have written the steps of construction. Now it's easy only. From B, we have to draw a perpendicular. That can be drawn using compass or using protractor. I will show you both ways. First one, I will show you how to draw using a protractor. You should just keep the protractor here at B. See the center point? This point should be coinciding with B. So you keep it here. You mark a point. Then from here, you just join. You will get the 90-degree line, which is the perpendicular line. The other way is to use a compass. For that, we have to draw a small arc here, a semicircle. With B as center, you have to draw a semicircle. Then, with the same radius, you cut one arc here and another arc here. Now see the center arcs. From here we are just cutting two arcs. One arc here and one arc from the other arc. Now if you join, again you should get the 90 degree. This is the 90 degree. Again this portion is not needed. I drew it to show that it is passing through the 90 degree point. So we need only up to this. I am going to mark it as D. So for this, the step of construction is draw BD perpendicular to AC. this BD that we have over here will give us the value of square root of 9.3, which we will prove just now. Okay, before that I am going to join O to D. So what will I get? I will get a right angle triangle. As soon as we see a right angle triangle, we should think of Pythagoras theorem. Here for this right angle triangle, I will draw it separately to show you so that we don't have to disturb the diagram. O, B, D. This is the right angle triangle. This one, the perpendicular one, we will call as height or the perpendicular P. And this one I am going to call as base. This is the hypotenuse H. Okay, hypotenuse, perpendicular and base. You can actually take any one of these as the perpendicular. You can take this as perpendicular and this as base, or this one as base and this as perpendicular. It is up to you. This is somewhat logical, so I have taken this as the perpendicular and this one as the base. This one will always be the hypotenuse. The side opposite to 90 degree will be the hypotenuse. Now our formula for Pythagoras theorem is h square equal to p square plus b square. Always this is the formula. Now we have to find out the values of all these numbers, that's all. Now you see OC is the radius. That is what we did. We used with the, we have taken now OC is the radius here. So OC is the radius. Similarly, OA is also the radius. Why do we call this as radius? It is starting from the center and meeting the circumference, this line segment. Similarly, we have OD. OD is also starting from O and meeting the circumference. So surely this is also the radius. Now what will be the radius of the circle, semicircle? This thing from A to C is 10.3. We have written here. So this radius should be half of this. AC is the diameter. So OC, the radius should be half of 10.3. 10.3 by 2. So OD also should be equal to how much? 10.3 by 2 only. So this thing here is 10.3 by 2. This hypotenuse, because that is also the radius. Now we need OB, the base. To find OB, we know OC is 10.3. BC is 1. OC is 10.3 by 2 and BC is 1. We just have to subtract. So we will write H is equal to 10.3 by 2. It is equal to our OD. And now we need OB. OB can be written as OC minus BC. OC is the radius. So that is also 10.3 by 2. Minus BC we took clearly. That was 1. Taking LCM, we will get 10.3 minus 2 by 2, that is 8.3 by 2. This is what we got for OB. So this is 8.3 by 2. This is our relationship between H, P and B. Now we will have to substitute H as 10.3 by 2, B as 8.3 by 2 and find the value of P square. So 10.3 by 2 the whole square equal to P, we don't know, no, this is our P, we don't know. So P square plus B. B is 8.3 by 2 the whole square. You take this to the other side. I am going to do the rest of the calculation here. P square equal to 10.3 by 2 the whole square minus 8.3 by 2 the whole square. Take the 8.3 by 2 to the other side. You can square it 10.3 into 10.3 by 4, then 8.3 into 8.3 by 4 and then subtract. It is a waste of time. You have already learnt a square minus b square in algebra. Use it. A square minus b square is a plus b into a minus b. So 10.3 by 2 plus 8.3 by 2 a plus b into 10.3 by 2 minus 8.3 by 2. So from this what do we get? 10 plus 8, 18.6 by 2 into, here we will get 10 minus 8, 0.3 gets cancelled, 10 minus 8 2 by 2 is 1. If you cancel this, you will get 9.3. Now you see we are getting the value of P square as 9.3. So what should be the value of P? It should be square root of 9.3 only. So P square is 9.3 means P should be square root of 9.3. So what we have over here, this was P, no? This should be how much? This is square root of 9.3. So now it is a small last step only. You have to measure this. Using your compass always, we have to measure BD using our compass. Now we have proved this is square root of 9.3. Now we will have to mark it, that's all. If you mark it, this is square root of 9.3. Now if you mark it on the number line, you are going to get the square root of 9.3. With this B as center and this BD as radius, I am going to cut an arc here. And I am going to name it as BE. This BE will give us the value of square root of 9.3. This is the new arc, and here we have to write BE equals square root of 9.3. So for the last step, I will show you the step of construction, the last and final step. What is it? With B as center. B as center and BD as radius, what did we do? We have cut an arc here at the point E, which where is it lying? On the line AC produced, meeting AC at E. And what do we have? B is equal to BD. BD is equal to square root of 9.3. This is the complete answer along with the justification. This portion here is called the justification, and these are the steps of construction.